Good evening, everyone. Okay. Okay, excellent. So welcome back. Today is the webinar on differentiation. Has anyone done differentiation in school? Type 1 for yes, 0 for no. Okay. We got 2 ones. That's nice. Okay. Differentiation is a really important topic. We decided to put it early in the COMPOS program because it's so important, right? Differentiation plays a very major role in physics. So, for example, if you take the distance, if you differentiate the distance, you get speed. And if you differentiate speed, you get um, uh, differentiate speed, you get acceleration. If you differentiate momentum, for example, you get force. And if you differentiate work, you get power. So derivatives have a play a very important role in physics. Okay, I won't be able to go in detail in how this works today. Today, I want to teach you to differentiate. And this neat diagram shows roughly the difference between differentiation and integration. Differentiation has 4 rules: the chain rule, the power rule, the product rule, the quotient rule, and that's it. It has 4 rules, or actually 3. I wouldn't say the power rule is actually a rule, it's just a formula. You got 3 rules. If a function is differentiable, so that means if you can find a derivative, you use one of the 3 rules, and you can find the derivative of every single function. And that's it. Very easy. Integration is the opposite of differentiation, is going back. And integration is approximately infinity times harder. So this is assignment 3. Assignment 3 is going to be an integration. Of course, we're not doing the whole integration. I don't think there is a person in the world who knows 100% on integration. You learn to integrate all your life. Yeah, it took me. I went to university for 7 years, and I still consider myself to be mediocre at integrating. Okay, so integration is a true art. We will begin to study it. There's no way we can do the whole topic. Differentiation is different. Differentiation is really easy. It's only 3 rules that you need to know, and that's it. Once you know these 3 rules, you can differentiate any function if a derivative exists. Yeah, because not all functions it's not always you can find a derivative. Okay, so let's start. So let's talk about what a derivative is. Like, what is it? What's the easiest way to understand what a derivative is? And the simple answer, what is a derivative? The derivative is the gradient. Derivative is the gradient. And to illustrate that, I have a function here. And what I'm going to do is I'm going to try to find the derivative. That means to find the derivative means to find the gradient. Of course, the gradient of this function is different everywhere. Okay, let's start. Let's start with -2. So when x is -2, the gradient is, well, it's positive. I would estimate it. I won't do a very good job, but I would estimate that the gradient is approximately +10. I don't know if it's +10, but that's my approximation. Because if I draw a line along the graph, it looks like a line with gradient 10. Does that make sense? Do you understand what I mean? On a scale of 0 to 10, please. 0, I don't understand what you're talking about. 10, I understand fully. The gradient of this line is 10. When x is -2, the gradient is 10. And that's what I do here. When x is -2, the gradient is 10. Now, as you can see, the gradient changes. And let's say when it's -1, the gradient is less than 10. So I would estimate this to be, I don't know, 5, +5. So when it's -1, when x is -1, the gradient is about 5. I'm doing a very rough, this is a very rough estimate. Interestingly, at this point, when x is -1/2, the gradient is, the line is horizontal, so the gradient is 0. So the gradient is 0. When then you go down, like when it's 0, it's approximately -5. The gradient is -5. So when x is 0, it's -5. Now here at 1, it's approximately, I'd say -6 or -7. Okay, -7. 1 is -7. Then again, it becomes 0. At 2, it becomes 0. Well, oh, sorry, not at, yeah, roughly at 2, it becomes 0. And then it starts growing. So when it's 3, it's about +7-ish, 7-ish at 3. And then at 4, well, at 4 it's really, really high. So it looks like that the derivative looks like this. So derivative is the gradient of that function. So first the gradient is positive, then it's 0, then it becomes negative, then it's 0 again, and then it's positive again, just like here. The gradient is positive, 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 then it becomes 0, then it becomes negative, 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 and then it becomes positive. So if you find the gradient, so this is problem number 1, I think, in the assignment. For the plot given below, estimate the velocity at several points in time. So you need to find the gradient. You need to find the gradient of this graph at every point. Like, I don't know, when t is -2, when t is -1, 0, 1, 2. Okay. You can use the template in the appendix. If you have the old version of the file, it doesn't have the. This is the appendix. Please download a new version from our website. If you don't have the appendix, it's there. It's on the website. So apologies, I added this yesterday. The appendix is just an empty graph. Okay, so let's see if we're even close. And if we got the graph, here it is. This is the graph. And let's see if I was at least somewhat close. This is the actual derivative, that graph. Well, I'd say I was pretty close to the actual value. Okay. So this is the original function. This is f of x. So this is y equals f of x. And this y equals f prime of x. This is the function. And this is the derivative. Derivative of f of x. This is the function, and this is its derivative. Sometimes you just write it y and y prime for simplicity. Or you can write dy dx. This is another way of saying the derivative. df dx dx. So these are all the same thing. All mean the same. Mean the same. Did you understand how I got the black graph from the original graph? On a scale of 0 to 10, please. That's excellent. It's very good. D. D represents the change in, but I will talk about this in a minute. Okay. So differentiation from first principles. So as I said already, the derivative is the gradient. So let's take a function like y equals something simple, 0.25x squared yeah, let's take this function. Okay. Let's choose a point on the graph. Doesn't matter which one, but let's take, I don't know, this point. And let's call this point x. And this would be y, of course. Okay, this would be f of x. F of x. I go f of x. So if I move to the right of x, so let's say I make a small step, and this size of the step is delta x, change in x. So this becomes x plus delta x. And now I am here. F of x plus delta x. What's the change in y? Well, if I want to find the gradient, let's call this point A and this is point B. Gradient of AB. What's the gradient of AB? It's change in x, yeah? So change in y divided by change in x, right? We've all studied that. Change in y divided by change in x. Well, that's pretty much it. Change in y over change in x, and the derivative is dy dx. I'll explain the difference in a minute, but yeah, that's pretty much it. The derivative is the gradient. Now, the gradient of the line AB is delta y delta x. But delta y is this minus this. So that's equal to f of x plus delta x minus f of x divided by delta x. Right? Does everyone understand this? Do you understand that this is the gradient? And do you understand how I got this? On a scale of 0 to 10 again, please. So all I'm doing is I am finding the gradient of the line AB. The gradient of line AB is change in y over change in x. And change in x is delta x, of course. But change in y, that's this value minus this value. That's why I written this here. Now, what I do is I move B closer to A. Move B closer to A. So B, let's say B moves here. Delta x becomes smaller. Delta x becomes smaller. You can imagine that, right? I hope. B. So you can think of it like this. So this is a graph. This is A. This is B. The graph is like this. B1. It's like this. B dash dash like this. So as I move closer to A, this delta x becomes smaller, smaller, and smaller. As we say that as delta x tends to 0, as delta x becomes closer and closer to 0, that means as b gets closer and closer to A, the line AB becomes tangent to the curve. So AB is a is segment. Yeah, AB is a segment, segment, and at some point it just becomes tangent. So this is the tangent to the curve, So the definition of the derivative. Definition. The derivative of f of x is the limit of f of x plus delta x minus f of x divided by delta x as delta x tends to 0. And this is denoted as dy on dx. That's the definition. So is the gradient of the line AB but as the point B moves closer and closer to A, basically B becomes A and the line becomes tangent. Limit is that's a tough question. Shrey, thank you for asking. Limit is the final value as delta x tends to 0. Dy. Okay. Delta y divided by delta x. So delta y means change in y. And delta x is change in x. But as you make it limit delta x tends to 0, delta x becomes very, very small. This becomes dy over dx. So what does that mean? Dy simply means infinitely small change in x. And dx means infinitely small change in y. X change in y. Infinitely small change in y. So this is just change in y, and this is an infinitely small change in y. So the limit of delta y as x tends to 0 is dy, as a matter of fact. So it becomes delta y, dy. Delta y becomes dy. So delta y is a large change and dy is an infinitely small change. Does that make sense? Limit. Well, what's 1 divided by x? The limit of 1 over x as x becomes infinitely large. Well, we can't divide 1 by infinity because infinity is not a number. But we can tell what happens to this value when x becomes very, very, very big. When x becomes very, very big, this becomes very, very small. So we say the limit of 1 over x as x tends to infinity is 0. Does that make sense? The limit x squared divided by x as x tends to 0. Let's look at this one. By 0 it means closer to 0, yes. Yeah, it gets closer and closer to 0, but the limit is 0. So the limiting value, you're getting closer to what? To 0. Look at this one. You can't substitute 0 because you can't divide by 0. You're not allowed to divide by 0. But you can say that what happens as x becomes closer and closer to 0, because you can simplify that. So this is equal to the limit of x over 1 as x tends to 0. And of course, as x tends to 0, this thing becomes 0. Okay, so that's the use of limit. So now let's find the derivative from the first principles. So this is a very important task that you need to be able to do. We'll get there. So suppose differentiate from the first principles, find the derivative from first principles. So what you do is you find f of x. Let's not use, so f of x, that's 2x. Now f of x plus delta x, I simply substitute x plus delta x. So it's 2x plus delta x. Easy. So I just write down f of x is this. F of x plus delta x, I just substitute x plus delta x. And then the derivative dy on dx, or simply I could say y prime, which means the same thing, is the limit of delta x tends to 0 of f of x plus delta x minus f of x divided by delta x. So I substitute that in. So it's the limit delta x tends to 0. F of delta x, so it's 2x plus delta x minus 2x divided by delta x. Now limit delta x tends to 0. And 2x, this is 2x plus 2 delta x minus 2x, 2x cancels, divided by delta x cancels, and I get 2 over 1. The limit of 2 is the limit delta x tends to 0 of 2, which is obviously 2. What is the limiting value of 2? Well, 2 is always 2, so it doesn't matter. Delta x doesn't matter, so the answer is 2. But this is a straight line. Straight line, and the gradient is 2. Of course, the derivative is 2 because the derivative is the gradient. So this is a very convoluted way of saying that the gradient of this line is 2. But at least we are able to verify that. Like, I mean, of course it is 2. I'll do 2 more, probably, or 3 more, just for you to get the hang of it, because it doesn't actually require too much thought. So this is another one. So to differentiate that from first principles, of course, I write down f of x, the function. The function is x squared. F of x plus delta x, what's that going to be? Well, we just substitute x plus delta x instead of x, right? So we just drew x plus delta x squared. Does everyone understand this bit? Please let me know on a scale of 0 to 10. Do you understand that if this is true, then this is true? So I literally just substitute x plus delta x instead of x. Okay, there was a 5. So look, a function works like this. F of x, if x of x is x squared, f of a is a squared. F of zebra is zebra squared. F of x plus delta x is x plus delta x squared. Does that make sense now? Isa? Yeah? You understand? Okay. So a function, whatever you put in, of course, if zebra is part of the domain, okay, if zebra is not in the domain, then you can't put the zebra in, but that's a different story. Okay. And then I write down the limit. So y prime, the derivative of y, is the limit as delta x tends to 0 of this minus that. So x plus delta x squared minus x squared divided by delta x equals limit delta x tends to 0. We just now open the brackets. We open these brackets and it gets x squared plus 2x delta x. So this is just 2 times x times delta x plus delta x squared minus x squared. And as you can see, x squared cancels delta x. Now we break it down. It's the limit of delta x tends to 0 of 2x delta x divided by delta x plus delta x squared over delta x. So that's equal to limit of delta x tends to 0 of delta x cancels. So it's 2x plus delta x cancels delta x. But delta x tends to 0. Well, if you do a plus b squared, you have a squared plus 2. There's a question, where did the 2x delta x come from? 2ab plus b squared. That means x plus delta x squared is x squared plus 2x delta x plus delta x squared. Does that make sense? And then you simplify this, so you divide by delta x, you get 2x plus delta x. But delta x tends to 0. That means the whole thing, this becomes 0. So the limit is just 2x. Right. So bottom line is, if y is equal to x squared, then the derivative is 2x. The derivative of x squared, this can also be written like this, or x squared prime is 2x. This is another way of writing it. Or you can say dy dx is also 2x. This is another way of writing it. Okay. Now, if I gave you the exact same question right now, do you think you'd be able to do it on a scale of 0 to 10, please? Okay, not bad. Let's do one more. X cubed. Y equals x cubed. We need to differentiate x cubed. Y equals x cubed. So f of x is x cubed. F of x plus delta x is x plus delta x cubed, of course. And we can simplify this right away. So how do you open the brackets? Well, you can just do this. Delta x multiplied by x plus delta x and x plus delta x. And you just oh yes, binomial. Of course, you did the binomial theorem. You don't need that. Okay. Sorry, I forgot. You can use the Pascal's triangle. 1. So that's going to be x cubed plus 3x squared delta x plus 3x delta x squared plus delta x cubed. Okay, so this is the third line of the Pascal's triangle. I mean, if you're not convinced, just open the brackets. Okay, but well, it's like that. Now the derivative of y prime, is the limit of delta x tends to 0 of x cubed plus 3x squared delta x plus 3x delta x squared plus delta x cubed minus x cubed. So it's this minus that divided by delta x. Now x cubed cancels, and we can see that delta x also cancels. Delta x cancels, cancel, cancel. So what we get is the limit of delta x tends to 0 of 3x squared plus 3x delta x plus delta x squared. What is this limit equal to? What do you think? If delta x becomes 0, what does this thing become? Indeed, 3x squared. 3x squared. So the derivative of x cubed is 3x squared. Y equals x cubed dy dx, or y prime. Sorry, let's just use the same notation. I mean, honestly, we use the easiest notation. Y prime is 3x squared. And now the last one I won't do from the first principles. I'll just give you the formula, and I'll leave it to you to derive. If you have y equals x to the power n, then y prime is going to be n multiplied by x to the power n minus 1. And this is what they call the power rule. I don't really like to call it the power rule. It's just the derivative of x to the power n. How does that work? Example. Well, if y equals x cubed, then n equals 3. That means y prime is 3, so n, multiplied by x to the power n minus 1, so x to the power 2. If y equals x to the power 4, what is that going to be? Four x cubed. Very good. Y equals x to the power 17. X to the power 16. Okay, everyone's getting it? Please ask me a question if you're not understanding. What happens? Very good. If you have y equals 4x to the power 5, then you keep the 4. Nothing happens to the 4. 4 stays, and then you just do the normal stuff. So times 5 x to the power 4, which makes it 20x to the power 4. One more. Y equals 3x to the power 6. Y prime, that's going to be 3 times 6, so 18x to the power 5. Okay, any questions? Okay. All right, let's do a tricky one. Y is x to the power minus 2. minus 2 x to the power minus 3, indeed. Minus 2 x to the power minus 3, of course. What if y is square root of x? Well, square root of x is x to the power 1/2. So that's going to be 1/2 multiplied by x to the power 1/2 minus 1. So 1/2 minus 1 is minus 1/2. Y equals cube root of x to the power 7. Or that can be written as x to the power 7/3. So y prime is 7/3 x to the power 7/3 minus 1, so 4/3. So the formula is n multiplied by x to the power n minus 1. Okay. So let's differentiate. So this is some questions. Now, the derivative, I haven't mentioned that, but the derivative of is linear. So the derivative of a sum is the sum of derivatives. So if you're differentiating this, you can find the derivative of x to the power 4 separately, plus the derivative of x to the power minus 1 separately. So the derivative of x to the power 4, that is 4x cubed. This one is minus 1 x to the power minus 2. And of course, this doesn't look pretty, so you want to simplify it. So 4x cubed minus 1 over x squared. Full stop. Make sense? Do you understand this question on a scale of 0 to 10, please? Okay, we'll do some more. So if we want to differentiate that, that's going to be 10x to the power 4 minus 6x to the power minus 3. Okay, and you can write it as 10x to the power 4 minus 6 over x cubed. It's another way of writing it. If you don't like negative powers. I don't mind negative powers, but if you don't like them, you can write it like this. But this is also a valid answer. So you differentiate that. So the 2 stays. So multiply by 5 becomes x to the power 4. Power goes down by 1. Once again here. So 6 stays. 3 over 2 goes into the front. So if you differentiate that, there's going to be 18 over 2. 18 over 2 x to the power 3 over 2 minus 1. So it's 1/2 plus 2 times minus 1/2. So minus 2 over 2 x to the power minus 1/2 minus 1. So minus 3 over 2 plus 4. Okay, so we haven't discussed what to do with 4. But let's take a function. This y is 4. What is, it looks like a horizontal line. What's the gradient of a horizontal line? 0. So y prime is 0. So the derivative of any constant is 0. So the derivative of c, so c prime is 0. The derivative of a constant is 0. So it's plus 0. Right? We can simplify that. This is 9 square root x minus, oh, that's 3 over 2, 1 over x to the power 3 over 2, which can actually be written as x square root x. You don't have to do it like this, but this is one way of doing it. Okay, so here there's a division. You can't divide, but you can simplify it first. So we're going to simplify it first. It becomes 2x cubed divided by x to the power 1/2 plus 3x divided by x to the power 1/2. And that simplifies as 2x to the power 3 minus 1/2. That's 5 over 2. Plus 3 x to the power 1 minus x to the power 1/2, x to the power 1/2. And if you differentiate now, over 2 plus 3x 1/2, if you differentiate that, it becomes 10 over 2x to the power 3 on 2 plus 3 over 2x to the power minus 1/2. Okay, so you can write it as 5 x to the power 3 over 2. That's x times square root over x. So x times square root x plus 3 over 2. It can be written as 3 over 2 square root x. Full stop. Now here, this is a multiplication. We haven't done multiplication, but we can expand again, right? We can expand the bracket. So that's the same as x cubed minus x squared plus 2x. And now if we differentiate, y prime is 3x squared minus 2x plus 2. Because the derivative of x to the power 1 is 1 x to the power 0 plus 2. Okay. The derivative of x is 1. And it does make sense because the gradient of y equals x is 1. Gradient of y equals x is 1. Right? Okay. This one. We open the brackets first. So we write 3x to the power 4 plus, open the brackets, so 6x cubed. And now we find the derivative. That is 12x cubed. So 4 times 3 plus 6 times 3. So that's 18x squared. That's it. We've done. So the next one, you need to open the brackets first. So it's 3x, so it's 12x squared plus 3x over x minus 8x minus 2 over x. We can simplify this as 12x squared plus 3 minus 8x minus 2x to the power minus 1. And now we can find the derivative is 24x plus 0 minus 8 plus 2, because the minus 1 goes here, so it becomes plus 2, x to the power minus 2. So that becomes 24x minus 8 plus 2 over x squared. Does everything make sense so far? Please let me know. And just excuse me for a second. Well, how would you differentiate a function, Liz? Well, this is technically not a function. It's called an implicit function, and you need to use implicit differentiation. So x squared plus y squared equals r squared. The problem here is that you can't express y in terms of x. We can't express y in terms of x in a single way. If you know what I mean, y is plus or minus r squared minus x squared. There is an uncertain, there's a ambiguity. So this is not a function. Not a function. Because in a function, if you know x, you have to know y. We'll talk about this later on. I think it's assignment 4. We'll talk about this, but you can use implicit differentiation. This is a year 12 topic. Implicit differentiation. You need to differentiate. Need implicit differentiation. Something we're not doing today. Yeah. One more interesting derivative. So so far what we have learned. Summary. We learned that the derivative is the gradient. Derivative is the same as the gradient. We learned that the derivative of a function can be found as the limit delta x tends to 0 and f of x plus delta x minus f of x divided by delta x. And third, we learned that the derivative, if y is x to the power n, then the derivative of that function is n x to the power n minus 1. 4, we learned that the derivative of x is 1 and the derivative of a constant is 0. So that's the summary so far. Now, the derivative of sine and cos, I will not show you how to do it from the first principles. I will just give you the formula for today. We don't have enough time to do it from first principles, but I hope you will have a look at the derivation from the first principles. So very simply, the derivative of sine is cos. Easy to remember. And the derivative of cos is minus sine x. Okay. Note that x is in radians. Let's just have a look at it and see if that actually makes sense. So y equals sine x and y equals cos x. Right. Yep, no worries, Asa. Okay. Look, the blue one is sine x, and the green one is cos x. And now what we're saying is that the derivative of sine is cos. Look, when sine, the gradient of sine, here, the gradient is 1. X is in radians, yes. The gradient is 1. And see, cosine is actually equal to 1 at that point. 1. Here, the gradient is 0. And cosine x is actually 0 at this point. Here, sine x has a negative gradient. The gradient is -1. And cosine has the value of -1 at this point. And so on. So the derivative of sine is cos. And the derivative of cos is minus sine. I won't show that, but you can verify that by yourself. So the gradient of the sine graph is the cosine. Okay. And an important thing that if you have sine 3x, what do? Well, you take the 3 out. The derivative of sine 3x. So just formulas. The sine x is cos x. Cos x is minus sine x. Now sine ax, if there's a value here in front of x, is just a cos ax. Something you just memorize for now. Something just believe me. Cos ax is minus a sine ax. So the derivative of sine 3x is going to be 3 cos 3x. Easy to remember. Just take the 3 out and keep the 3 here. Right? This is going to be minus 3 sine 3x. 4 sine 7x is going to be 28 cos 7x. And here is going to be 18 minus 18 sine 3x. Does that make sense? Any questions? So 5 in our summary, that sine ax is a cos ax, and cos ax is minus a sine ax. So we've learned this. Now, I really want to make sure that you understand every single point from the summary, because we'll go ahead, and if you don't understand this, you'll really have trouble understanding the rest. Okay, this is critical. The rest is not critical. So this is critical that you understand this. Critical. So on a scale of 0 to 10, do you understand every point here? So the derivative of x to the power n is that. The derivative of just x is 1. The derivative of c is 0. The derivative of sine is cos. The derivative of cos is sine. Okay. So we get to the 3 rules, the 3 magic rules that I've mentioned in the beginning. And we'll start with the easier rule, the product rule. And the product rule looks like this. Before I mentioned that, okay, so there's one more thing that I wanted to go through in the summary. 6, which I've mentioned, but that if you have a derivative of f plus g, that's just f plus g. So you can differentiate them separately. And the same with the minus. Okay, so very straightforward. That's what we've used that rule just. Okay. So this rule works for f, but for product, what are the product of two functions? So you know, what if you have a product of two functions, u multiplied by v prime? If you have the product of two functions, what do you do? Well, the rule is like this. You differentiate the first function and you multiply it by the second function plus the first function multiplied by the derivative of the second function. This is the product rule. So let's have a look here. This is u, this is the first function, and this is v. So the derivative of y is going to be u prime v plus u v prime. So derivative of u, what's the derivative of u? Well, let's write it like this. X prime multiplied by sine x, so times v, plus u, which is x, multiplied by sine x prime. So y prime is 1 multiplied by sine x plus x multiplied by cos x. So the answer is y equals sine x plus x cos x. This is the answer. So it's a very easy rule. Like honestly, you just. So once again, this is u, this is v. So u prime is going to be x squared prime cos x plus x squared cos x prime. Y is 2x cos x plus x squared. Cos is minus sine x. So y prime is 2x cos x minus x squared sine x. Do you understand this rule? Do you understand how to use it on a scale of 0 to 10 again, please? Asking for feedback once more. Okay, so some 8s. Can you tell me which part do you not understand? Please let me know. I'd love to verify. Well, I'd love to explain. Or maybe should I just do another example? Oh, because, well, it's some cos x. So x times cos x. Cos x is a function. And that's a function. You you break them down until you get something you can differentiate. You cannot differentiate like you can't differentiate x cos x because that's not a function. Well, I mean it is a function, but you don't know the derivative of that. So you have to use the product rule. You can't differentiate that straight away. You can differentiate x squared because you know the formula. You can differentiate sine because you know the formula. That's why you break them down into two. So here, this is the first function, and this is the second function. So you just differentiate the first one. So y square root of x prime. Then you don't touch the second one, x squared plus 3 plus square root of x multiplied by x squared plus 3 derivative. Well, we've already differentiated that. Square root of x we can differentiate. So y, that's x to the power 1/2. So it's 1/2 x to the power minus a half. That's the derivative of this, multiplied by x squared plus 3 plus square root of x multiplied. Now the derivative of this is 2x, and the derivative of this plus 0. But we will write plus 0. So that's it. 2x. That's the answer. So I'm not sure I can do more complex examples than that because they're all not very complex. Like, okay, 3x to the power 7 multiplied by sine 4x. It's your choice what you choose as u and v. This is u and this is v. So I'm going to do y prime. So I differentiate this. So it's going to be u prime v plus u v prime. It's going to be the derivative of this is 21 x to the power 6 multiplied by v, which is sine 4x, plus u, which is this, 3x to the power 7, multiplied by the derivative of this, which is 4 cos 4x. And then you can simplify, it's 21 x to the 6 sine 4x plus 12x7 cos 4x. Is that better? So Rafi and Shrey and Maria, does that make more sense? Okay. So this is rule number 1. And honestly, it doesn't get harder than that. For the product rule, it doesn't get much harder than that, of course. You can as long as you know the rule, it works without any exceptions. And remember this one. Remember this thing. We did it. We opened the brackets first. But you don't have to. You can use that. You can do the product rule here. So you can do. So this is u, and this is v. So you can do u prime v plus uv prime. So y is equal to the derivative of this, which is 6x multiplied by x squared plus 2x plus u, which is 3x squared multiplied by v prime, so the derivative of this bit. So that's 2x plus 2. Now if you open the brackets, so 6x cubed plus 12x squared plus 6x cubed plus 6. Oh, really? Seriously? This is just bizarre. Okay. Okay, oh no, it's not bizarre. So 12x cubed plus 18x squared. And I think that's the same thing as we did here. So here we first, yeah, it is. So first we open the brackets and then differentiate it. And here we use the product rule and we got the same, obtained the same result. Okay, the quotient rule. The quotient rule is slightly more difficult than the product rule. The quotient rule formula looks like this. If you have u divided by v prime, if you have a derivative of a fraction, it's going to be u prime v minus u minus uv prime. So the difference, instead of plus, you have minus now. And what students usually get wrong, they get the wrong order. They get uv prime minus u prime v. That's wrong. So it has to be the top one minus the derivative of the bottom one, and then divided by v squared. So that's the formula. So for this one, it's the derivative of u. So this is u, and this is v. This is u, and this is v. So u prime v minus uv prime divided by v squared. So y prime is u prime, so it's x, so it's 1, multiplied by x plus 2, minus u, which is x, multiplied by v prime, so which is 1, because the derivative of x plus 2 is 1, divided by v squared, so x plus 2 squared. And then you just need to simplify that. It's x plus 2 minus x divided by x plus 2 squared, which makes it 2 over x plus 2 squared. That's it. This one. So it's u, this is u, and this is v. So y is uv prime minus u, what? Sorry, now I've made the mistake. U prime v minus uv prime over v squared. So u, that is 6x multiplied by v, which is x plus x squared, minus u, which is 3x squared plus 2, multiplied by v prime. So v prime, that's 1 plus 2x, divided by v squared, so x plus x squared squared. I don't want to simplify that, but of course, you open the brackets, you simplify. But that's not the point. The point is just being able to do this. This one, sine x over x. Well, that's y prime is going to be sine x prime x minus sine x x prime over x squared. So sine x is cos, so it's x cos x minus 1, x prime is 1, so it's 1 sine x divided by x squared. That's it. Beautiful. Tan x. Now tan x doesn't look like doesn't look like a fraction. So what do we do with it? Somebody help me. Tan x. Sine over cos, of course. Sine x over cos x. So it's sine x over cos x. So it's sine x prime cos x minus sine x cos x prime over cos squared x, because v squared. And that's equal to sine x, that's cos x, cos x, cos x, minus sine x times minus sine x. So there's going to be plus sine x, cos squared x, which is cos squared x plus sine squared x over cos squared x. What is cos squared x plus sine squared x? Somebody who did year 10 compos assignment, it is 1. It's 1 over cos squared x. That's it. So the derivative of tan, and that's something you can remember, is 1 over cos squared x. Interesting result. You can put that in. Now the last one is the chain rule. The chain rule is by far the hardest rule to understand. The chain rule, also known, aka, is the derivative of a compound function. Right. The derivative of a compound function. If you have a function within a function, so if y is equal to f of g of x, f of g of x, okay? We call this the inside function, and this we call it the outside. The derivative is going to be the derivative of the outside function in terms of g multiplied by the derivative of the inside function. Like, you will probably start using this a long time before you start understanding it. At least this is what happened to me. I learned how to do it. Maybe 2 years later, I understood the rule. It's a very tricky rule to understand. It's not as tricky to start using it. So basically, what I'm saying is, to differentiate a compound function, you differentiate the outside function and the inside function separately, and you just multiply them. How does that work? Well, here, this is the inside function. And this is the outside function. Sine of something. To differentiate that, we find the derivative of the outside function. What's the derivative of sine? Cos. Yes, so it's cos. We don't change the argument. We just write cos x squared plus 3x. We just differentiate as if this was just x. But then we multiply by the derivative of the inside function. So multiplied by 2x plus 3. And that's it. So it's the derivative of the outside function. The derivative of sine is cos. So we differentiate it as normal, but then we multiply it by the derivative of the inside function. Do you think you understood this example? Give me a yes or no, please. Okay. So let's look at this one. This is the inside, and this is the outside. Outside. So when to differentiate that, we treat as if it was we just say that it's g to the power 7, right? Like, it's like something to the power 7. So it's going to be 7 g to the power 6. Well, g to the power 6, that's just that. 7x squared plus 4x to the power 6. We just differentiated it as if it was x to the power 7. But then we multiply that by the derivative of the inside function, multiplied by 2x plus 4. That's it. So it's not as hard to use it, but it is hard to fully understand it. Yeah, so I really hope you will be able to use it. Okay, let's do some more examples. Y equals cos x to the power 7 minus x cubed. Can you do it by yourself, please? And then I'll give you like 30 seconds, and then we'll verify that. How to understand it. Well, you have to use the notation. Like this function, you can write this as sine of g. Yeah, sine of g, where g is the inside function, sine of something. So you could say dy dx can be written as dy dg multiplied by dg dx. Dg dx, that's just the derivative of the inside function. And this is the derivative of the outside function. This is the notation. This is Newton's notation. Newton invented this notation. Okay. All right. Have you managed to do this one? So minus sine x to the power 7 minus x cubed. Very good. Yes. So you differentiate the outside function. And then you multiply that by the derivative of the inside function, which is 7x to the power 6 minus 3x squared. Well done, Sam. That is exactly correct. And this can be applied to anything. Like y equals tan of sine x, for example. You know that the derivative of tan is the outside function. So it's going to be y prime. So it's going to be 1 over cos squared sine x, because we know the derivative of tan is 1 over cos squared sine x, multiplied by the derivative of the inside function, so cos x. Okay. Y equals square root of x. No, that would be too much. X cubed, 4x cubed plus sine x. Well, The outside function is the square root. So there's going to be 1/2 multiplied by 4x cubed plus sine x to the power minus 1/2. So we just differentiate that as if it was square root of g. And then multiply that by the derivative of the inside function, so which is 12x squared plus cos x. And that's it. So I hope you got it. There are different ways to learn this chain rule. The last thing I wanted to do is some practical applications. It's not as much practical as it's just an interesting observation. So let's write down the area of a circle. Area of a circle is pi r squared. And now let's differentiate that with respect to r. Well, so r is the variable. Oh, I did. Okay, then, sorry. Then let's not do it. Thank you. Thank you. I forgot. 2 weeks. 2 weeks has passed, and I've completely forgot. Understand it though. Okay, let me just do it. It will take literally a minute. So the area is pi r squared. If you differentiate that, it's going to be pi multiplied by 2r, which is 2 pi r, which is the formula for the circumference. Weirdly, the derivative of area is yeah, that's fine. The volume of a sphere is 4/3 pi r cubed. And if we differentiate that with respect to r, it's so 4/3 pi multiplied by 3r squared, right? 3 cancels, and it's 4 pi r squared. That's the area of a sphere. Area of a sphere. Okay. Yeah. So why is this is happening? Because if you have a circle and the radius changes slightly, increases by a small amount, and this thickness is dr, there's a small change in r. The area of this stripe, if you were to unwrap it, you could make it into a rectangle. And this is dr, thickness dr, and the length 2 pi r. So the added area, so the shaded area is 2 pi r dr. And shaded area is actually is the change in area. Change in area, so it's a change in area. So dA, change in area, is 2 pi r dr. And if you divide both sides by dr, you get dA over dr, which is 2 pi r. Sorry, I'm not expecting you to understand this. Okay, this is going slightly beyond what we're doing, but this is the derivative. So just the derivative is dA over dr, which is 2 pi r. But yeah, this is the small. If you increase the radius slightly by the amount dr, the area increases by 2 pi r dr, and that's why the derivative is 2 pi r. And I will stop here. It's exactly the same for the sphere. Tan sine x. Okay, very quickly. You know that the derivative of the tan x the derivative of tan x is 1 over cos squared x. But that means that tan g, or if it's not x, if it's something other than x, it's 1 over cos squared g multiplied by g prime. So tan sine x prime makes 1 over cos squared sine x multiplied by sine x prime, which is 1 over cos squared sine x multiplied by cos x. And I have to go, unfortunately. See you all. Well, when do I see you? Webinar, year 11 webinars. So the next webinar is on the 19th. I really have to go, unfortunately. I have yes. Right. Okay. If you do have questions, please ask me at the end of the next webinar.